do is go to the sheet metal tab, which is obviously what we will use most in this session. So you can go to here and, oh, I'm in BIM apparently still. So I need to switch to mechanical workspace, of course. And then after it's switched, you can go to the sheet metal part. You can already see there are the sheet metal part is already made for you in this case. And you can see that is correct sheet metal because it has this light blue shade. Correct in that sense that, yeah, that there are no issues in the bends or anything. Now we want to see the unfolding, but we want to see it associatively so that whenever we edit the unfolding, we also edit the 3D model and vice versa. To do that, you can go here to the Unfold/Export tab, and there associatively unfold the body. Then you, just like a regular unfolding, you select the face. Here we will select the seat of the seat. And there you can start your unfolding from. It already gives me a warning, namely that it's self-intersecting. And if I zoom in, you can indeed see that here we have some interferences here as well. So we will try to edit that. You also see them highlighting red here. So to do that, we will now this unfolding is actually associative with this 3D model, but it's a bit tricky to see or to see that they're associated. So what we will do is we will go to the View tab. There you have Windows, and you can tile actually all the tabs that you have open vertically. And if you have the same like me, that you also have the Start tab that's being tiled again, you can just minimize it. Or yeah, minimize it, I hope, or close it maybe. Yeah, closing. Closing is easier. Then you can tile vertically again, and you will see them next to each other. And if you need the Start tab again, you can always type go to Start, I believe. Because yeah, now you close it. Normally minimizing also works. So we now tiled them next to each other. And what we now want to do is edit the 3D part and see the unfolding change. So you need to click in the view or in the tab to activate it. And then you see it by the look from that appears. Similarly, you can tap, you can click in the unfolded view, and they will be associated with each other. Now I want to go to the bottom back left. So from the look from, to do that, I hold down Control and hover over the look from. Then I get all the down options, such as the down back left. And then you should see this part. And we will try to switch around these bends and junctions so that we can actually try and see if that would give a better unfolding. So first of all, we will change the bend here. So you can highlight a face, and then you can switch it to a junction. It should appear in your quad at your cursor. It's also under the sheet metal sub-tab of the quad, create junction. But if you wouldn't see it appear, you can also click the face and go back to the sheet metal tab. And there you can find a junction in the modify ribbon. You can find junction, and you have some sub options that we will see later. And one of them, the first sub option is actually create a junction. And then it will create a junction from this bend that we had before. And then if I now pay attention, once I click in the other view, it will update itself, and you should see less red in this area. So now it's updating itself, and yeah, you see less red. Apparently the view tilted so that you can easily see. here is now unfoldable, yeah, as opposed to before. But what we actually did now is, if I go back to the 3D view, is that we made this part entirely loose. It isn't connected anymore. So what I now need to do is create a new, yeah, you don't see it appearing here either because, yeah, it's just separate. It should be a separate unfolding, not of that main body. But if I attach it again with a band, it will reappear. So how do I do that? Similarly, you can select the face, only the face. So either your prioritization of faces is on and you can select it immediately. Or you hold down Control if you're in solid selection mode, then you can access the face. If you have access to face, which you can see by the little orange highlighting, you can normally see it in the quad, create band. But if you wouldn't see it, it's because you haven't used it recently. And if, yeah, sometimes it's also not in the sheet metal here. And then you can go here to the bands section next to where we had the junction before, and you can choose create bands. And once I do that, you see that it automatically makes the relief again. It makes the band like I wanted instead of the junction. And now if I click here, you should see the extra flange appear. So yeah, here it is. Here you have the extra flange, which is now not clashing with the other unfolded representation anymore. Of course, we need to do the same at the other side. So for that, I click back in my 3D model. I go to down, back, right. And I do the same. I hover over the band. And now it should be fairly in your recent commands. I create the junction. Here I select the face and I create the band. And you have here a relief, again, automatically made. And if I now click again, you will see this flange shift places so that it's not aligned here anymore, but now it should be, yeah, it should be the same and it should be symmetrical. So now it's still not unfoldable. So we will see the other direction of the associativeness in action, and that is from the 2D unfolding to the 3D model. So for that, I will first rotate my view a bit. So here you see these two flanges are approximately the same height. And then you have to pay attention to the inner one, because I will edit this one in the unfolded view. So here you see that they clash in this part. Now I can push-pull this part here, the face that's like inside the flange, inside the little flange. I can push-pull it to access it. If your highlighting of prioritization of faces should be on, so that you can easily cycle between all the faces under your cursor with the tab key. So press tab once and you cycle. And once you have this face, you can actually push-pull it. Once you push-pull it, oh, I'm push-pulling in a wrong face, it seems. So I have this one. Yeah, now I'm push-pulling the correct one. So here you see that I'm now push-pulling this, this face. And pay attention to here the hotkey assistance. You don't want the one with the blue, the enable push-pull subtract, because it might create a hole where you had the geometry before. So you make sure that it's disabled. You can do that. You can switch between enabled and disabled with the control toggle. So I press control to access the gray cross instead of the one with the blue. And then I push-pull it back with 10. And if I push-pull it back with 10, you see it immediately turns blue. And also, if I rotate, you see there's a small gap, but that's what we wanted. And now we can see what it does in the 3D model. So if I click now here, you should see something change at this inner spike. And normally, yeah, it's already applied. It's probably the other side, yes. So, but the other side was symmetrical and it was equally high. So you saw a change here. So I can try again. This side. So I will rotate my view so that I can access the other flange easily. Right, and then I can select this face again with tab, push pull it, make sure that it's not subtracting, push pull it back with 10. Oh, yes. And then it turns blue here. So it means that it's unfoldable. And then I click here and you should see this change, hopefully now this time. Yes, and I saw it changing. So that's what you want. It's really associative between this one, between the unfolding and the 3D model. And now you can choose what you do. Either you save this unfolding as a separate file, but yeah, you can always access the unfolding from the 3D model, of course, as well. So you could also just save the 3D model and close this one. Once I close it, it's not even necessary to save it. The changes are already done in the 3D model. So I just click no in this case. And then here I can maximize it. So next to the cross, you have a maximize button. And I can maximize it so that we can proceed the next exercise without these tiled views. Yeah, that concludes the first exercise. And now we will go to T-junctions and tabs. And for that, I will pop up my start menu again with the command go to start. So here it is, and then I can open my drawing. This time we need the folder 15 advanced sheet metal, the second exercise T-junction and tab, the starter files again, but if you would be lost, there are also intermediate files because this is a fairly long exercise. And then you have here the drum. And then I can open it. And the first thing which you might notice is that this one is not blue, it's gray. It means that that it's not sheet metal yet. It's just a solid geometry that you might have imported or that you created in BricsCAD itself. And we want to transform this to sheet metal. Now I could select one piece and go to the convert to sheet metal under sheet metal create. I could go there and then I will just create one part in sheet metal. The rest will still stay gray. If I want my entire drawing to be converted to sheet metal, I just press this button first. And then you have the sub option entire model. And if I click that one, you will see everything turning blue. So all the parts turning blue, which means it's now sheet metal. But as there are no bends or junctions yet or anything, it will not be manufacturable, certainly because the bottom part here is still attached to the circle here. So what I can do is I can start with this inner bracket to make it manufacturable. The first thing which you need to do, you can also do it from the inside, is to highlight an edge and turn it into a bend. Again, the same thing applies. You can access it through the quad if you already used it, or you can go here to bend, create bend. So either you select the entire model or you select just one edge, and both will work. The only difference is that the edge will do it edge per edge. It will transform it into bends. If I select the entire model and choose bends, it will give bends to my entire model, but as I only have one, this is also a valid option. So next thing we want to do is we want to zoom in here on this part. If I zoom in, you actually see there is a gap here. We don't want this gap. We want it to be manufacturable and that this remains in its place here. So what I want to do is I want to create a junction out of this. How do I do that? Well, it's similar to the junctions we created from the bends or from the edges before. We select the face and we go to the junctions, but this time you need to select a sub option, namely the connect flanges. This is to also just if it's a real junction, it's also to create T junctions. So that's what you can do with here to the face. And I hope you can still follow me because I get a message that my internet is unstable. But here now it doesn't do anything yet because you just need to press enter. And if you press enter, it will connect the two flanges together in a T junction. Now that's not still not entirely what I want. I actually want to have tabs here in the outer drum. How can I do that? Well, in the mechanical browser, if you will look, you have a T junction here. That's extra created. It wasn't there before. If you would look later, you can see that it wasn't there before. And if I make sure that this is a bit open, you should see Tjunction Properties. And here you can change it. Here you can right click on the T junction. Here you just see the properties of the gap and so on. But here, if you right click it, you can switch to TTab. And you will see that two tabs appear here. And if I would isolate this part, you would see that two tabs are nicely created. Actually, in the mechanical browser, we have now two T junctions and one TTab, which is the middle part here. And you can still edit the distance or the slot number if you want more slots. And you will see that if I show everything again, that it always creates the nice holes here and that your design intent is respected. You want it to be flat with this face. That's the case. So this is how I want it. Well, almost. The thing I still want is to create here like extra flanges that hold it a little bit in place. Well, actually, I want this part to have an extra flange. So how do I do that? You can select an edge or hover over an edge. And then in sheet metal, you should see the create flange edge command, or you go here to the flanges and then edge flange. Once you clicked on the edge, you can do that, or you can first click here, select, and then it asks you to select the edges on the flange. So I select this one, and then I press enter to accept that I want this value. And then if you hover to the correct side, you will see that you have now an extra flange at your cursor. And I can type in the values, 12 for the length of the flange. And then I would like 90 degrees so that it's straight along with the drum. And then I can press enter to accept these values, and you will see that it even creates a nice little relief here. So that's convenient because that means it becomes manufacturable. You also want to do the same at the other side so that it's a bit fixed in place. and then you can create the flange from the quad, for example, in this case. And then I can type in 12 and 90 again and accept it. Yeah, you can cycle between the dynamic dimensions with tab. And then you can see this is how I want it. Now I will place some constraints to make sure that if I push pull one part, that it behaves like I want, because now you see that the flange, it doesn't stay the same size, the length of that flange. So I want to constrain from this face to this face to this, I don't know how you call that in English, to that minor face. You can select these two, and then you will see they're 10 or 10.05 apart. That's because the design intent said that we wanted this entire thing to be 12. And with the bend, this results in from this till this, it's 10. And now I want to constrain them together. You can go to the sheet metal. You can stay in the sheet metal tab, and you can here go to the parameterize, and there you find distance. So I select the distance, and then it says, okay, it's 10 in the parallel direction, let's say. And then I select that, and I do the same for the inner one, because the inner one would have the same problem otherwise, that it doesn't stay the same length like I want to. So I select these two faces. Again, a distance constraint. And before I also did this, but just accept the default 10 by pressing enter. Then it will also always stay 10. Then the next thing I want to do is just make sure there is one fixed element. The constraint engine always works best if there is one fixed element which doesn't move places where you kind of start your parameterization from. And that is, in this case, this outer face with the tabs in. I just click it, and then I fix it in place with this this lock icon. And then you should see also this fixed constraint appearing in your mechanical browser. And now I can retry what I did before, push-pulling a face. Push-pulling one face will actually take all the, will respect your design intent. It will stay 2 millimeters thick in this case. And now, since we constrained these flanges, they're staying 12 long, let's say, their entire length. And now I can push-pull it back towards, away from the little bend, from the curved bend that you see here. And then I can press 10 and accept it. So you should see it shift. And you also can notice that here the tabs, they nicely moved along, the holes moved along, so everything stays as you want it because of the automatic design intent functions that come in the sheet metal. And then the next thing which we want to do is actually we want this to form a little slope so that it's like a funnel that it goes inwards. To do that, I will select the face again. So just like we push-pull the face, I now want to rotate the face, but actually we will rotate this entire flange by doing that. If I would if I would call the manipulator and rotate the solid, then you will rotate the entire thing and you don't get the desired effect. So make sure you have selected the face. And then you can long click here in the bottom right corner. If you click in the bottom right corner, it will the manipulator will appear at the right location right away. So you just long click and it will appear here. If it would not appear on the correct location, you can always move it with these little white grip points, and you can move it and snap it to any snap location that you have in your drawing. Then I select this one that goes in the parallel with these flange. And then if I wait a bit, yeah, my preview comes along, and I don't want it to be this exaggerated. I just want 8 degrees. And I can press tab to already see a preview, whether I like it or not. And I press enter to accept the 8. And then you see that actually everything is respected. This stays parallel to this face, and this stays 12. So it's like I wanted. So this shows that you can easily manipulate and push, pull, and rotate flanges. And again, here the tabs, they just come along as it's a feature. Now, we also have 2 features, which are the bend reliefs. Those 2 gaps here, those orange gaps. It's a little bit easier for the X of the exercise if we dissolve them. Dissolving means that you will transform them just into regular geometry. They are not a feature anymore. They're not really, you cannot change the type of the relief anymore. It will just stay this same geometry, but that's no problem. So we can just dissolve them. You can select them both by holding down Control. You can select both at the same time. Right click on the bend relief name, and then you can choose dissolve. And then they're actually dissolved. You don't really see any change. It's just now, yeah, you cannot edit the type of the relief anymore. Then what we also want to do for the rest of the exercise to go to be as we want it, we want to put the context of the body tree. So that's this one. You want to put it onto the local context, so not the global context, which is the entire the properties of the entire drawing, let's say, or of the entire solid. You just want the properties of this solid only, and this will allow you to give you a lot of options, among which here the thickness. Now it's 2 millimeters, but you can change it to 3 by typing 3, and just pay attention here to the thickness. And then, if I wait or if I accept it, you can see a change to 3 millimeters. And it's respected, again, the design intent. This is still nicely touching. This is still nicely touching. My corners are still similar. This will still be 12 long. So it's as I wanted. That's how easily you can change the thickness of a part of your sheet metal. So just go to the body, put it on context for solid, and change the thickness. Here you can also, you have a lot of other options that you can inspect. On the help page, you can find more information about them. That we will not dive into right now, but we will try to fix the bottom of the drum now. Since it's not manufacturable yet, this part, if I select it, it's the entire drum, also the upper part. So this cannot be bended anyway. So the only way that we can do this is make a junction over the entire rim or in the entire edge here, and make some tabs so that it stays in place. How will we do this? We will, go here to the root node, which is drum shell, so the upper element. And then if you click that, you will see a few options. among which also the thickness, but also among which you will have the tab slot number, which will control the amount of tabs that you make. So if it's 2, you will, whenever you create an array tab, it will create 2 tabs only. And you have the tab distance field where you can unfold it, and you can say it's the thickness ratio that you're looking for, and that's actually how long I think how long the element is as opposed to its thickness. So that's the ratio, and you see that it's 20 here. So, or yeah, I'm not 100%. Yeah, that's I think the meaning of this one. So here we want to, if you want the same result as me, you want to put it on 100. And then here you have the tab slot number. If you put 0, it will, it will create, wait, I will place it back to 2. Here the thickness ratio is the distance. I said it wrong before. It's the distance, which is 200. You see the grayed out value, but you cannot change this right away. So either you change it to an absolute value and you can type in an absolute value, or you choose thickness ratio, and then the tabs will be placed as opposed to the thickness of the sheet metal. So we have a thickness of 2 millimeter here. And if we put the ratio on 100, it will do 100 times 2 is 200 millimeter, that the tabs will be placed out of each other. So it will be spaced each time 200 millimeters. But yeah, now I will have only 2 tabs. I hard-coded this value 2, so this will take priority, and the tab distance, it will not be symmetrical. I think it will create 2 tabs indeed, but it will just go, it will start from one edge. That's, I think, what will happen. If you don't want this and you just want as many tabs as possible with spacing of 200 millimeters as opposed to each other, then you can put this on 0, and it will do an automatic each time I want, every 200 millimeters I want a tab, and it should be nicely go around the entire edge. Then this is what we need. So we put this on 0 and this ratio on 100, and then that's done in the drum shell node. This will set the values for creation of the tab, of the array tab. So upon creation of the array tabs, it will look to these values. Now, if you have a straight edge and you do an array tab on a straight edge, you will be able to see it here, just like this one, an array tab. Here, you will see that you can still change this number of slots here to 3, for example, and we should see it change. Oh, no, 3 is too much, probably 1. Normally you should be probably, because my distance is fixed, so I cannot change the amount of slots. You need to play with these values a bit to get the correct result, namely 3 tabs if you would want that. So that's the array tab that you can edit. If you have a curved or a banded array, you can only control the distancing with these creation values. So these will be taken upon creation, and these will be applied. And since it's a band, we don't have the functionality to create it like a feature that you can still edit. So that's why we set these values beforehand. And once we set these values, so tab slot number on 0 and the ratio under tab distance on 100, we can actually create the array tab. How do we do this? We go to the modify option, and then you see the tab. It's underneath the junction. You have an option tab. If I open up this option, you see create array tab, and I click this one. And now it will ask me, to select a junction or curved hard edge to create an array tab, or we do the inverted curved tab, or a single tab. And in this case, I want an inverted curved tab. And then, yeah, you also can create the curved hard edge or the inverted curved tab. You can select the curved hard edge to create the inverted curved tab. That's what it says. So we can select this part only. So now you need to have edge selection on, because otherwise it will be difficult for you to access this edge. I select it, I press enter, and then you see that it now created these nicely spaced tabs. And then I accidentally was in the previous command again. But then here you see that it's almost 200. It's nicely spaced, 194 millimeters, where it's this is 194, but then together with this distance 8.11, that will create the 200. So it's from middle of the tab to middle of the tab that we have the 200, which we set at the creation properties. So that's our parameters, let's say. So that's that. Now you would think it's almost finished. It is indeed, but you still see that if I select the bottom, the drum shell also comes along. So I still need to create this into a junction as well. And I can create the junction. And now if I control to select my entire solid, then I can create that. I can select the bottom alone. So now it's manufacturable. So this is almost there. The only thing, now we're almost there. The only thing we still need to do is here, this is not manufacturable yet. These are actually two separate parts. I can select both of them at the same time. And in the sheet metal tab of the quad, I can create bends, or at the same location where we had it before, here. I can create the bend. And if you create bends, it will actually do everything automatically. If you create it, if you launch it on an entire solid, it nicely makes these reliefs. So everything is manufacturable right now. And then the last part is to unfold the bodies. You can unfold this bottom from the bottom. And then, oh yeah, I did an associative unfold. So yeah, now it's associative, that's also an option. But we can unfold the body regularly in the same drawing. Then I need to click to have a position for this part, and I need to enter to accept it. And then I also can do the same for the other parts, such as the drum itself. It will create these bend lines, which are for a small bend, like a not so sudden bend, let's say. And then I can unfold these little parts again. So click in your drawing and enter to accept. And then from the bottom as well, here, yes, and then we have a small part. And in total, you should have 5 parts. So we're still missing one, which is, of course, this one with the tabs. If I unfold this one as well, and I forgot to enter the previous one, and I enter, then you have all your parts like you would wish, and they're all unfoldable, so that's good. And